Yeah, welcome back to Integrated. This is mathematics. So today I'm gonna show you how the e to the power x, so the exponential function will be formed with. Yeah, it will be formed with the limitation of let n goes to infinity of what? 1 plus x upon n to the power n. So this is the case I'm gonna show you now. So we need to get the expansion of this right hand side of this expression first of all, because some students really they are struggling with why we are not able to take this carry this into this square bracket. Sorry, yeah, why? Because of this one, right? Because of this one, because there is a variable, so we can't break them out, right? So I'm going to show you how we can do it. Let me go for another slide. Okay, let's start it. From my right hand side, limit n goes to infinity. Let me expand that. The first one is nc0. 1 to the power someone is just 1, right? So I will neglect it simply. nc1 x upon n to the power 1. After that, nc2 x upon n to the power 2. Likewise, at the rest it will be ended up with ncn x upon n to the power n. Yeah, let me close that bracket, right? Okay, now you all guys know that nc0 is nothing else, just 1. That is just 1. So nc1 factorial n and minus 1 factorial 1 x upon n, right? Likewise, factorial n minus 2 factorial 2 x squared upon n squared. Likewise, let me show you only just a few terms how the simplification will be worked. This is not quite difficult, but it seems just different. Let me do it for you. This is pretty much easy to do, right? Let n goes to infinity. First of all, let me show you. We can break each of these terms distinctly, because there is a summation between each of them, so we can do likewise. But the case is here. Let me round it off. This is the guy, right? So you can see infinity upon infinity. This is not defined. So in that case, we will meet such discontinuous scenario. So what we can do? Really, we can form. We can make some. We can make some arrangements. So we may be able to cancel out these discontinuous scenarios, right? So let me show you. Factorial n is nothing else. So you can cancel these two out. N minus 1 factorial. This is just n minus 1 factorial. The first one becomes x upon factorial 1. Here, okay, as we expected, it was reduced into that stage, right? Okay, this is what the Maclaurin series we are gonna form, right? Because really you are familiar with 1 plus x upon factorial 1 x squared upon factorial 2 likewise. So that's my final target, to show you how it is being formed. Likewise, factorial n times n minus 1. So n minus 2 factorials, these two will be cancelled out, right? Because of this one in denominator also factorial n minus 2 factorials, this n square. We can cancel out this one easily. Now you can see there is one more discontinuous scenario, but that's pretty much easy to cancel out by taking our little n, right? I'm not gonna show you in this slide, because I don't have much space here, right? But you can simply take our little n and cancel out it, because we need to make it a continuous function to find out the limit, right? Then you can catch there is a particular strategy, x squared upon factorial 2. Likewise, it will be kept up to infinity. Yeah, most of the students I have seen that in my studies also they were caught because they are really struggling with this end of this implication. So let me show you the end. What would be happen at the rest of this? Yeah, let me take a coffee. Right. Okay. So let me erase these top of this screen. Yeah. Okay. So what really what's going on? What's going to be happen in this case? Here, this will be just one. This is just one, but x to the point upon into the point. The case is once n goes to infinity. Once really, I forgot to show you that this can be expanded, right? You need to expand it. I'm gonna do everything very briefly. Just I want to give you the main idea only, right? So the final term. Just pay attention on this final term. So what will be happened here? Already we were looking for the expansion of this guy. So we know that with binomial expansion, there is an expansion of binomial expression. So you know that the property of binomial expansion is what's the index? Rather than index 1 and plus 1, much of terms we will have after the expansion. So once n tends to infinity, how many terms we will have at rest? Infinity plus 1, much of terms will be generated. So it means that the terms will be infinite number of terms will be generated in this series. So this is the Maclaurin series, but I have not shown you using the Taylor series. I have used the expansion on the definition. I have gone through the definition. One day I will show you how to do it using the Taylor series. Right? Okay. So thanks for watching. I am Sapmal Sena, the Sasangasagara.